Lesson objective for today is A.5C. A.5C states that we will use, translate, and make connections among algebraic, tabular, graphical, or verbal descriptions of linear functions. So what we intend to do here is we're going to basically go through each of the different possible representations of a function, okay, as we were just stated in the lesson objective. So let's start with the scenario problem. It says Russell does yard work on the weekends to earn spending money. He charges $3.50 an hour. He wants to buy a portable CD player that costs $130. How many hours of yard work must he do in order to pay for the CD player? Okay, so to begin with, we want to make a table showing the relationship between the number of hours worked and the money earned. Okay, so this is our tabular description, as it's called. So for one of these tables, basically you want three columns. You're going to have your input, x, which in this case could be the number of hours, h, that Russell worked. You're going to have the end result, or output, which in this case will be the money saved or money earned. We'll use S for money saved. And then you're going to have your rule to represent what it is you're doing to the h to find the S. So if he's charging $3.50 an hour, we would have $3.50 times h. Okay. If this were written in function notation, the last column would probably say S of h. Okay. That's our idea of function notation. So the savings is determined by the number of hours. So we know that we're trying to find how many hours he'd have to work to earn $130. Okay, so we want to choose values for h that makes sense. Inputting negative values in for h probably is not going to do you much good. You don't work negative hours. You could start with 0 hours worked would obviously earn you $0. And then you could go up from there until you find the number of hours that would earn you $130. So tables can be somewhat time consuming. If you're building it from the start and working your way up, you might kind of skip ahead a little bit. Maybe you know that if he works 10 hours, that would just move the place value over one place, so that would be $35. So if you double that, 20 hours would double $35 would be $70. That's getting us relatively close. If you double 20 to make 40 hours, it means you'd have to double $70 to make $140. That's a little too much. So somewhere between 20 hours and 40 hours is going to be the correct amount. Okay. Now again, for purposes of this presentation, I don't have time to do 20 hours through 40 hours. That would take us quite some time. Let's try starting at 30 hours and just see where we wind up. So we put 30 in for h. So this would read 350 times 30. Okay, so earlier we said 20 hours was $70. I'm sorry. So this would be 10 more hours than 20 hours, and we said 10 hours was $35. So really, this is, for mental math, this is just 35 plus 70, or $105. Using the power of halving and doubling can really make mental math much easier to do. So we're not too far off. So if we try $31 hours, you wind up with 350 times 31, which would basically just add another $3.50. I shouldn't have put h there earlier. I'm sorry, that should have been a 30. So ignore the h, that should have been 30. All right, here we got 31. So again, it's just $3.50 higher. So that's going to be $108.50. Okay, so we're going to keep going up to 32 hours, 350 times 32, which again is going to add another 350. So it's going to be $112 even. Okay, and we keep this pattern going until we find the one that gives us $130. I've noticed, I don't know if you caught on to this, but every 2 hours is an additional $7. So we can probably skip another one here. Instead of doing 33, let's just go straight to 34 and say, okay, well, that's 350 times 34, which is really just going to be $7 more onto 112. So that takes me to 119. So let's skip another 2 hours here, go 36. 350 times 36. It's got another $7 onto that, so that's going to be 126. Okay, I gotta slow down a little bit here. Probably can't go another $7, right? That'd be too much. So let's just go 1, see what happens. So that'd be 129.50. Now, interesting, we were shooting for 130. 129.50 is only 50 cents shy of what we need. But if you really think about it, you go into that store to buy that CD player, and you hand the cashier $129.50, and he tells you it cost you $130 to buy the CD player. He's not just going to spot you the 50 cents, is he? He's going to make you come up with the other 50 cents. So in reality, stopping at 37 hours is not going to work because we're still not quite to what we need to pay for the CD player. So in this case, you would actually need to work 38 hours. And even though that does take you beyond what you need, it's going to give you enough to pay for what you need, to pay for the CD player. And it has some change left over. Okay? Alright, so we've created a table relationship between the number of hours worked and the total amount of money saved for the CD player. Now, this question says, what would be a reasonable number choice to use in the number of hours worked column? So basically our domain, right? Because our domain is our inputs. So we've kind of talked about this. For this problem, since hours is our domain, you could start at 0 hours. Alright, so H could be greater than or equal to 0 hours. And once you reach your $130 you need, you pretty much can stop working, right? You've got what you need to buy what you want. So in this example, our H would go up to 38, and that would be far enough. We wouldn't need to go beyond that. Okay, so hours from 0 to 38 would represent this scenario. All right, so then it says, what values would you expect to get in money earned column range? Explain your answer. Now this one's a little bit tricky. You can actually state this one a couple ways. Okay, now on that hours, we're going to assume that you only get paid when you work a full hour. Right, so when I say 0 to 38, that's really only doing the whole numbers from 0 to 38. Okay, so this isn't, we're not going to include decimals of hours, that you get paid decimal amounts of money in this example. All right, we're just going to say it's whole numbers only. Okay, and so this would be my domain, 0 to 38, whole numbers only. So that would affect your range. Your range would start at $0 if you work 0 hours, and it would go as high as $133, but it wouldn't include everything in between. It would count by $3.50 each time. So you could state that a couple ways. You could do it as a list. That would be quite a long list. You could still do what we did with the hours and say that it's everything from 0 to 133, but you would have to put the stipulation counting by multiples of 350. Okay, so using multiples of $3.50. Okay, so my range would start at 0, go to 133, and it had multiples of $3.50 each time. Again, assuming you're only getting paid when you work a full hour, not for partial hours. All right, so we've talked now about what the tabular representation of this is. It gave us the verbal representation. That's what we started with. And we've also spoken about what an appropriate domain range for this problem is. The next thing we'd want to do is look at a graph to represent this. So since everything was positive numbers, we only need quadrant 1. So for our graph, we would want to just represent quadrant 1. And we would say our x-axis is going to be our number of hours. And we'd say our y-axis is our savings. Okay, so the y-axis is in dollar amounts, and the x-axis is just in hours. All right, so we start at 0 here in both cases, and now we'd want to count by a scale that makes sense. Now, if we go back to our last slide, we said our domain is from 0 to 38. So it may make sense for this one to count by ones, so that you can see every possible data amount from 0 to 38 for what your earnings could be. If you wanted to, you could count by twos to reduce your number of data points visible, but still get what the pattern is representing this relationship. Okay, just depends on how specific or detailed, how much of your data you need to represent in your graph. The idea in this one, I'm not going to be able to fit it from 1 to 38 on here, but I just want to kind of give you the idea of what it's going to look like. So I'm just going to do the first few, and then you could continue the pattern until you get to the desired number of hours, which if you're using a graphing calculator, this is quite simple to set up. But for purposes of what we're doing here, we know that our rate of changes for every 1 hour, we're going to increase by 350. So the idea of your y-axis is you'd want a scale that stays the same all the way up. And so you could use whole dollar amounts. Again, we're trying to go from 0 to $133. So you could count by $5 amount increments or $10 amount increments if you chose to, and just realize that you'd have to be a little bit more, if you're doing it by hand, kind of spotting or ballparking where your points would go in between those $10 amounts for each hour. Okay, if you want to be super accurate and precise, you could make your hash marks count it by 350 each time. And then, of course, it would just be a one-to-one relationship. Okay, that's not typical in graphing that you do it that way. Generally, you just pick an increment that kind of makes sense for the data that you're doing. So I might do by tens up to 140, since I got to get to 133 for my dollar amounts. And then you're just going to kind of ballpark. So this is going to be right around here. 2 is going to be right around here. 3 is going to be just over the 10 mark, 1050. Okay, so 4 is going to be right around there somewhere. All right, and so you can see your points going up. Now, since we did say that we are not including partial hours, that we're only getting paid by the whole hour, in this scenario, I would not check my points. This would be a discrete graph. I would just leave it simply pointed. If it did include partial hours, like if you work 1.5 hours, then you will get $3.50 plus half of $3.50. Then it would be okay to connect your points and make a solid line through your points. Okay, so it really depends upon what the scenario lays out. Again, we're just assuming that you're just doing on the whole hour, so these would be discrete data. All right, finally it says write a function or algebraic description that describes the situation in problem 1 above. So we kind of did that with our table. If we go back to our table, this center expression, $3.50 times h, that's going to be the expression that creates our algebraic function using our input and output. So what that would look like is we'd say, okay, our output, which we're saying is our savings, in terms of h, our number of hours that we worked, should be equal to $3.50 times our number of hours. Okay? Now, if I asked you what shape of graph would you expect that to create, hopefully you could determine that that's a linear graph. Because what is the 350? Well, that's my rate of change, right? So the 350 is acting as my slope in this example. So I don't have a y-intercept because my y-intercept starts at 0. I work 0 hours, I get $0. You could put plus 0 in the end, but it's not necessary. So this is a linear relationship, and this is the function that describes my scenario. Okay, so these are what you're expected to do under this lesson objective. Change between all the different forms as needed for each scenario as it requires. Thank you for your time.